Welcome back. We're going to continue with the new task for classification. Um, and we're going to use the random forest algorithm, which is basically a number of decision trees in order to predict the lifetime values classes for our customers. And we are going to identify also the most important attributes for each one of the predictors in our nodes, in our decision tree nodes. I'm going to create the data set for training for our task here, which is based on the same table, dropping the LTV numerical column. I'm going to split the data into 75-25 ratio for training and testing. And I'm going to create the training machine learning objects, train X and train Y matrices, X with attributes, Y with labels, and the test data frame. Again, I'm going to create for this random forest machine learning model. I'm going to create a cost matrix table. If you remember from the decision tree, I think we have used the cost matrix. We can specify different costs for the predictions, being good predictions or bad predictions in our model execution, in order to convince the model or to force the model somehow to make certain or to avoid making certain predictions by increasing the cost of those predictions. I'm trying to avoid, in this case, the model to predict customers which are high as low customers, or customers which are very high, again, as low customers. Because in this case, I can lose a good customer because from a very preliminary classification, I'm going to drop them into the low bin, and that low bin doesn't have a importance for my business, and I'm going to forget about those customers. And that's why I'm trying to avoid these predictions, to avoid dropping good customers into the low bin. I'm going to run this cost matrix definition, and you can learn more about the cost matrix table in the link at the link here. And also I'm specifying the one parameter for the decision trees in my random forest. I'm specifying the tree term max depth to two nodes. For more information about decision tree or random forest, you have links below. You can read the documentation and understand how they work entirely with all the parameters and the attributes you can use in your model creation. And now I'm going to fit my model. I have created here a random forest model with my training data using the cost matrix I created. Once it is fit with my training data, I'm going to return the details of the model, printing those details. So it's a classification model using random forest algorithm. And we also have the attributes which have been identified as the most important ones. House ownership, in this case, marital status has been defined as important here. Mortgage amount, and if they have a mortgage or not, and how many maybe. And the transactions they have done on using in their bank account. And here is the importance of the attributes in my random forest model. You can see here also the importance value. They are not ordered. They are ordered by the name of the attribute alphabetically, but we can also order them by the importance value, and we can see here the attributes we have identified as being important, they actually have a value calculated here. So house ownership has 26%, marital status has 9%, exactly as the one we have identified in the attribute importance when we identify the attribute importance in the entire data set in the previous attribute importance task. And then mortgage amount has 35% and so on. So here are the attributes we have identified and with the importance value. I'm going to use this model to make some predictions and return the first 25 rows in the output. You can see here there are many wrong predictions. This model that definitely is kind of bad, let's say, in the accuracy from just looking at this table here. I'm also going to return the prediction probability for each one of the predictions. So you can see the model is my machine learning model is not very sure about the output or the predictions it returns for my data here. So you can see the probability of the predictions is about 50-something% to 61%. It's about half, let's say, sure that the predictions are accurate. And I'm going to return the top 2 highest probability classes in my models in my data set here. So in this way, for example, I can return multiple values for the same individual customer record, and also the probability that that customer is in one of those classes. For example, for the first customer, the first prediction is high. It is actually the good one because the actual value is high class. So this customer, the first prediction is high, but the model is 61% sure that this customer is high. But also the model considers this customer may be medium customer, but the probability that this customer to be medium is 24%. This is the prediction. For the second customer, the actual class is very high. The model predicts it is a high. It is wrong. And the second value it predicts is medium. So again, it's very wrong. So none of the top 2 predictions is the actual value, the actual class of the customer. So you can see this machine learning model is not accurate at all. Even in the first 2 predictions, the actual value it is not there, so it's wrong in both cases. And let's see the actual score of this model. We're using the pre-labels to compare it with. So the score of this model is 61%. It means that it is really, really bad, and we cannot use it to make some real-world prediction. But we can tune it, or we can change the model directly. We can change the algorithm, not create a new model with a new algorithm. So we have 2 choices, or we can use AutoML to improve it, to get the best model with the best algorithm. I'm trying to tune it here. I mean, I increased the number of tree depth to 3. So from 2 to 3, we have now 3 nodes between the roots and the leaves. And this is one. I have a new model with new attributes, with new details here. So you can see now we have totally different attributes that have been defined as important, and also we see the importance value for each one of them. in this list here. So we have in total 29 attributes, but only 4, 6, like 12 or 15 have been identified as important, and we have the importance value here. And now let's see the score of the new model with the tree depth of 3 here. And we have increased the accuracy from 61 to 66. Well, it's still a bad machine learning model, and we're not going to use this model definitely into a production case. So this is it. This is how you can use it. Thank you very much.